Hello everyone, welcome to our lesson. Today we're going to be talking about empirical probabilities. This is our first lesson. Now I want to give you a warning. In my experience, I have noticed that when I teach this class, probabilities is one of the most challenging concepts. With that being said, I would like to encourage you to come to student help hours or find a tutor at the Math Learning Center if you're having issues with probabilities. Okay, again, probabilities is going to be one of the most challenging concepts that we see in this class. Today, we're going to talk about empirical probabilities. Empirical probabilities are probabilities that we find by actually performing an experiment. So in this lesson, we're going to look at experiments. Your first learning objective is to identify outcomes, events, the sample space, and the event space of an experiment. Your second learning objective is to calculate probabilities of an event based on a given experiment. So let's go ahead and start by talking about the vocabulary that we're going to see in probabilities. We're going to explore the vocabulary by looking at some examples. First, let's go ahead and talk about a probability. What is a probability? The probability of an outcome is the proportion of times the outcome would occur if we observe a random process an infinite number of times. So here, we're talking about a proportion. It's going to be a decimal between 0 and 1. This value is going to tell us the proportion of times an outcome is going to occur if we were to perform an experiment infinite number of times. We're going to see some examples below. Again, first we're going to focus on the vocabulary we see in probabilities. In exercise number 1, we're going to look at a random process, which is rolling a fair die. You can think of this as a random process. You can also think of this as an experiment. We're going to assume that we want to roll a 5 or a 6. A fair die is going to have 6 faces. In one face, we're going to have a 1. In another face, we're going to have a 2. Another face is going to have a 3. Then we have a face with a 4, a face with a 5, and a face with a 6. The chances of rolling any of those numbers is the same. So that's what we mean by a fair die. So again, here we're assuming that we want to roll a 5 or a 6. We're going to be exploring the vocabulary we see in probabilities by looking at this experiment. Okay? So a experiment is an activity that has specific results that can occur, but it is unknown which results will occur. What is the experiment in this case? The experiment in this case is rolling a die, or rolling a fair die. In part B, we have a blank is the result of a experiment. This is known as an outcome. What are the outcomes of rolling a die? So what are the outcomes of the experiment we're looking at? When we roll a fair die, we can get a 1, we can get a 2, a 3, a 4, a 5, or a 6. Those are all the possible outcomes of rolling a fair die. In part C, we have a blank is a certain outcome of an experiment that you want to have happen. This is known as an event. Again, this is the outcome that you're wanting to see. Give an example of an event of rolling a die. Here, we're going to assume that we want to roll a 5 or a 6. So I'm going to write 5. That could be one of the events. I'm going to write 6. That can be another one of the events. Okay, and I can go ahead and provide more details here. I can say rolling a 5 or rolling a 6. Rolling a 5 is an outcome that we want to see, so we call this an event. Rolling a 6 is an outcome that we want to see, so we call this an event. Now, in part B, we have a blank is the set of all possible outcomes of the experiment. This is called the sample space. We usually denote this using SS. And so if we're going to provide the sample space for this experiment, we're going to use set notation. We're going to write SS is equal to, we're going to open a curly bracket, and we're going to list all the possible outcomes. We have 1, 2, 3, 4, 5, and 6. So again, we're talking about a space. We're talking about a set, the set of all the outcomes. So I know that in part B, we listed all the outcomes. In part B, we're saying this forms a set. We call this the sample space. Now, E says a blank is the set of outcomes that make up a event. This is what we call a event space. We can use a capital letter. We can go ahead and just use E. We could also use A. We can use B, C. It doesn't matter what letter you use. Okay, I'm just going to use E. And so if we're going to provide an example, we can go ahead and say the event space is either rolling A5 or rolling A6. Those are the outcomes that I'm wanting to see. Notice, these are the events that we saw in part C. Now in part E, when I go ahead and write the event space, we're using set notation because this is the set of all the outcomes. To compute probabilities, it's often useful to think about the sample space and the event space. Those two together can help you find probabilities. Let's go ahead and look at one more example where we have an experiment and we're thinking about the sample space and the event space. Suppose you flip a coin twice. Each time you get heads or tails, and you are interested in all the combinations of 2 coin tosses that give you at least 1 head. So at least 1 head. This is what you want. If I flip the coin twice and I record what I got, I wonder how many times I'm going to get at least 1 head. So with that being said, we're going to identify the experiment, the sample space, and the events. So the experiment here is flipping a coin twice. It's really important that we mention that. We're not just flipping it once to see what we get. We're flipping it twice. Once we flip it twice, we're going to record what we see. So what is the sample space? What are all the possible outcomes? It might be the case that I flip the coin once and I get heads, and I flip the coin again and I get heads again. So one possible outcome is HH. Now, another possible outcome could be that I flip the coin once and I get heads. I flip it again and I get tails. So another possible outcome is H. Now, it could be the case that I flip the coin and I get tails, and then I flip it again and I get heads. And the last one here would be flipping the coin once and getting tails, flipping the coin again and getting tails. So the last outcome we see is TT. It doesn't matter if you write them in a different order. The order of the outcomes here doesn't matter. Now, what would be the event space? So this is going to be the set of the outcomes that you're wanting to see. And I want you to go ahead and do this on your own. Let me make a note. It says you want to see at least 1 head. When you read at least 1, that means a minimum of 1. That also means 1 or more. So go ahead and think about the event space.